Knock, knock. Who's there? Oh, good, you're going to participate. To. No, to whom? So we've established that none of you are potential English majors. You're all possibly in the right spot. All right. I've been debating a little bit about how to do this tonight. Should we run it like a game show? Yes. Yes? All right. We need, who's book smart? Who's a straight A student out here? Straight A student? All right, come on up, straight A student. Let's see here. Who's, how long is this cord? All right. Who's street smart? Who knows how life really works? I see lots of finger pointing. You're all still single, apparently. All right, we got this guy in the back. All right. Now, who just likes to be up on stage in front of everybody? All right. Sorry, I got him first. All right. Mr. Ego. Okay, come on over here, guys. I actually set up this microphone for you, but it happens to be where we're not. Let's move over there. That way people can hear what you have to say. I promise not to try to humiliate you. It will just happen. Fair enough? All right, so here we go. Here's your first challenge. I have here these 3 containers. Two of them are marked. If I take this one and I put the negative facing this way, and we align it with the positive, okay? Now I'm going to take this, and it doesn't move. That's the problem. All right, I was wondering about that. Okay, now if I reverse them, and I take this again, and I take this again, now it rolls to the positive, right? And now, if I face positive and positive, it rolls the other way. So straight A student.
Yes.
Oh, we turned that mic off. Tell me, hello? Tell me what's going on here.
I would guess that the magnetic field is manipulating the metal properties that are inside that to...
You think we've got magnets in here?
Sure.
All right. Street cred.
Well...
What do we got?
He took mine, so... Aliens.
Aliens. You know, I live in New Mexico now. That's a wholly appropriate answer. Mr. Popularity.
My answer. I just thought it was cool.
You just thought it was
that's
cool.
why I'm up here.
All right. You win. There are no magnets. It was a trick. All I have in here is a little small stone. I can make it roll whichever way I want. These are just filled with air. That was a little unfair of me, wasn't it? Okay, that's fine. That's just to point out to you that things are not always as they seem, right? Sometimes there's some underlying principles there that can be very basic, but that are not immediately obvious. So let's move on to something a little harder. Shall we give you a group challenge?
Yes. Let's do it.
Let's do it. All right. You get a coil of wire. You get a magnet. And you get a light bulb.
Okay.
Your challenge is to light the light bulb.
So we want to create a current, so we run the magnet through here. Oh, this is cool. Slap. Oh, there it goes.
Hey, let's have a hand. All right. 10 points for straight A student. The points are meaningless, by the way.
I was shaking. I should get a point.
20 points for Mr. Popularity. All right. Good. This is pretty fantastic, right? So you knew that what?
That move a magnet through the coil, that it will create a current.
That's right. If you move a magnet through a coil, it will induce a current. And that current and change, when they're changing, can induce magnetic fields. And Street Smarts here knows that that's how electricity actually gets to your house. That exact same principle. There's not a guy sitting down there with a giant magnet pushing it back and forth all day, right? We use turbines and we do it a little bit more cleverly. But that's the basic principle at work. Okay, great. Let's go back to pitting you against each other. Should we do that? You like being on a team? I'm sorry. You are wearing the Superman shirt, however. So let's do a little mechanics here. Here we have two tracks, right? They're of different lengths. When I release the steel balls, which one is going to get to the end first? Mr. Popularity.
I'm going to say we're both going to do it at the same time.
Same time. All right. Street cred.
I'll go with the far one.
You're going to say that this one gets there first. Book smart.
So I was leaning towards that they end up at the same time because this first downward, or the second downward slope here is the same as the third upward slope over there, so they probably cancel out.
If you say this one of us has to be right.
That's true. Okay, I'll say this one because maybe since this track has more, this track has more surface area, so I have more friction overall. So maybe, I don't know, I'll say this one.
Okay, I think you're overanalyzing the situation a little bit.
Sure.
But that's okay, because you're the straight A student.
That's true, I got you.
Oh, all right. But why? Why were you right?
I just guess it's going to pick up a lot of speed going down there, and that won't.
That's actually entirely correct, right? Even though this other path is a little bit longer, for most of the path, the ball is traveling faster, right? Has a higher velocity, and it gets to the end faster. All right, 1,000 points for street cred.
Wow.
All right, so this is always fun. Let's do this. These are marshmallows, obviously. What do you think is going to happen when we put marshmallows in a vacuum?
They're going to get huge.
Okay.
That'd be awesome.
Street Smart says they're going to get huge. Straight A student?
I would agree.
Okay, same answer.
I'll disagree just because it's
You'll
cool.
disagree. You think they're going to get smaller?
I think no. Well, that's stupid though.
Well, no. Okay. Well, that's stupid. Why do you think that's stupid?
Because if there's no, I kind of agree that they'll probably get bigger.
Okay.
I like what they said. Though.
Why do you guys think they'll get bigger?
Air pockets.
Oh, I heard it in the audience.
Yeah. That's how
You guys think it'll be air pockets? You're going to agree with the audience?
Well, I guess it's because the idea is the atmospheric pressure is pushing down on it. So if you remove that pressure, then...
Okay. So atmospheric pressure. Should we give it a shot
Yes.
and see what happens? Nothing's happening. I think you're all wrong. Okay, I lied. It's another trick. I didn't actually turn on the vacuum yet.
well, that's not at all exciting.
I'm sorry. You have to be careful around me.
Yeah.
All right, we seem to have lost this. Oh, we'll be back on in a second. I will talk louder. Is that better? Yeah. Okay, great. All right, they are indeed getting much, much bigger. All right, so are they going to go back to their same size? Oh, hi there. And we got some music.
Nice. Same size?
Same
I
size?
say smaller.
No.
Smaller?
I say same size.
So, okay. Let's find out.
Oh no, they died.
Oh, they died. Because they were full of air, right? So that air was at the same pressure as the atmosphere, as you correctly surmised. And when we released the atmosphere around them, that pressure inside the marshmallow caused them to expand, right? But then we removed all that air and we had all these empty pockets. So it was harder for the air to get back in the marshmallow afterwards, right? Here. You can actually still eat them. You want one? Tastes pretty gross now, huh?
A little average, but it's okay.
So this is actually kind of a very important principle for you, personally, all of you. Right? Here's the same thing with a balloon. It's a little easier to see. You can pretend that that balloon is, in fact, an air pocket inside the marshmallow, right? And it will sit there and it will expand until, well, until the pressures equalize, so to speak. It will have to do a lot with the elasticity of the balloon, too. But this is also the same principle by which you live, right? Because in your body, you've got a set of lungs and a diaphragm. And when your diaphragm moves in and out, you collapse and you expand your lungs. So there you have it. Your lungs are marshmallows. Well, no, don't go tell people that. Okay. They'll think you're crazy. Okay, good. Let's do a chemistry one. I'm not a chemist, so these almost rarely work out. Should we try it? Sure. All right. So we have 2 sugar cubes here. As you know, sugar is a fuel, right? We burn sugar in our bodies for energy. We burn complex carbohydrates and hydrocarbons and sugar-like things in all other places in life. So it should be pretty easy to light a sugar cube on fire, right? What do you think?
No.
Have you ever lit a sugar cube on fire as a kid?
I've never done that.
No, I don't think so. You don't think it'll be easy? Why not?
Well, same reason, I guess, that.
Because you think I'm trying to trick you.
Yeah, it's all a lie.
It's all a lie. Oh, well, that's actually the wrong message.
I'd say you can burn it.
Okay, well, let's give it a shot here. Let's see if we can burn the sugar cube.
It'll make caramel.
It'll eventually make caramel, right? But it's not lighting. Well, what if we coat the sugar cube in ashes? Do you think that'll make a difference?
Yes.
Because otherwise I wouldn't have put it here, right?
Exactly.
Yeah.
This is the part where I'm not sure it's going to work.
Get it.
Oh. Well, we should have skipped this one. Let's give it a second.
Oh, no, there it
here.
goes.
Yeah? Oh, it is kind of starting on this side, but it's not quite the effect I've got before. So the ashes, oh, darn it. Well, let's pretend, we'll cut that out of the video.
Okay.
So the ashes can act like a catalyst. The carbon in the ashes will act as a catalyst to start the burning of that fuel that is the sugar. But that's pretty anticlimactic. All right, let's do something that I know will work. This is actually a lot more fun. We'll go back to electricity and magnetism. Right, straight A students seem to do pretty well with this stuff. All right, we have here various rings. Okay, this one's made out of brass. This one's made out of aluminum. We have a couple that are cut with slits. Some are thicker than others. All right, straight A student, what's going to happen when we put one of these wings on a coil of wire and run a current through the coil? While you think about it for a second, I'm going to grab this bucket.
So you're going to run a current through the coil. The ring will spin.
The ring will spin.
I'll guess that.
Okay. What do you think, Street Cred?
The ring's going to rise up.
It's going to rise up.
That's how I was feeling.
Okay, Mr. Popularity feels the same
I was
way.
thinking like it was gonna like levitate or something. Like,
Is
come
there going to be a difference between the aluminum and the brass?
Yes.
Why?
Because you have both of them.
Because I have both of them. He's catching on. These guys are quick studies, right? So let's do that, right? Oh, not bad. Should we see if the brass does any better? No, but I tricked you again, right? Because I used the one with the slot in it. So the slot doesn't work. Why?
It's not conducting.
That's right, because the circuit is open, right? We're inducing a current around the metal, and that in turn is creating a magnetic field,
Yes.
right? And it just so happens that it creates a magnetic field that is opposite to the one in the coil, right? So now we have a north pole on a magnet and a south pole on a magnet, and they fly apart, right? So this is fun. What do you think is going to happen when we cool the ring down with liquid nitrogen? All right, so we know that it induces a current. It acts like a little circuit. That current makes its own magnetic field. Does cooling the ring change anything about that current?
Yes.
Because otherwise I wouldn't have liquid nitrogen. See, he is going to make it in the streets. He knows how, he's catching on quick how this works, right? All right, so my goal is to see if we can get up to the ceiling here.
Oh, that'd be awesome.
I actually don't know if it'll go that high. Let it cool down a little bit more, though. This will be fun, right? So we can also do this. We can take an extra piece of iron, essentially, and we can make the core of our magnet longer. All right? What that does is that enhances the field that the ring interacts with. If we break something, I don't think I have to pay for it. Oh, that's not so impressive. I want that to go a lot higher. That was a little higher. Okay, good. So where are we at? You've got like 25 points, you've got 2,000 points, and you've got like 300,000 points, right? The points mean nothing. All right, so let's have some more fun with liquid nitrogen. Should we do that? Yes. Because liquid nitrogen, let's bring that doer over. Let's do that. Here.
Okay.
You don't have to touch it. I'll do it. I realize it might make you nervous. All right. If you'll notice, I've got two mics, and yet I've only been mic'd for about half the time. That is the beauty of presentations. All right, so we have this marshmallow. We have liquid nitrogen. Liquid nitrogen is pretty chilly stuff. It's just about 70 degrees above absolute zero. All right? That's really cold. Absolute zero is the coldest you can possibly get something in the universe, right? So we've got this marshmallow. It's pretty squishy. What's going to happen when we put it in the liquid nitrogen?
Become solid.
It's going to become solid. Okay, it's going to freeze, right? We also have, if you grab it over there, there's a racquetball. So racquetballs are pretty bouncy. They're a lot of fun, right? Pretty soft. We'll put it in liquid nitrogen too. Let these things cool down a little bit. So now let's do that popcorn. Why don't you hand me that bag of popcorn and that slot of spoon?
Oh, and spoon?
Yeah. All right.
It's like a fire. It's a campfire.
Yeah, except it's not smoke, right? What is it? He says it's like a fire. It's like a campfire.
It's fine.
What is it?
Vapor.
It's vapor.
Boiling.
That's right, because liquid nitrogen is essentially liquid air, okay? Now the molecules in the air in the room are zipping around roughly 700 meters per second, okay? When they're in a liquid, they're obviously going a lot slower, but as they boil off, they're actually only going about half as fast as the molecules in the room, right? This was kind of a lot of work just to make half-fast molecules, right? So don't think about it too hard. All right, great. You want some?
I'm all right.
A little bit.
Go for it. Oh, you don't want it. It's a lot of fun, huh?
That's pretty exciting.
That's one of my kids' favorite things to do. We have this marshmallow now, right? It's not so soft anymore. Uh-oh. Oh, why don't you toss that back up to me? Thank you. Where did my hammer go? Oh, I think it's still in that kit. I'm sorry. Because now this marshmallow is not such a marshmallow anymore, right? We didn't actually quite get to the core, but you can eat that too. It tastes a lot like astronaut ice cream now. All right, you want your own scoop of popcorn?
I'm okay.
Yeah, everything we eat here is going to be a little gross. But we have the same deal. Let's see here. I think this is now ready. We have the same deal with our racquetball. Our racquetball isn't very bouncy anymore. In fact, it's pretty brittle. It wouldn't be very easy to play racquetball with it. Oh, we didn't quite freeze that all the way either. I don't want you to wait forever while we freeze things, but I think we got the point across there. And so we've got one last thing to do with liquid nitrogen, and this is a fun one. I'm going to have to ask you to leave the stage. Let's have a hand for our contestants here. Oh, wait. Don't go away empty-handed. Now you can just go away disappointed. All right, so that's the fun with liquid nitrogen, right? Now as we saw, oh, this is enough still. Ooh, that's getting chilly. So as we saw, liquid nitrogen is liquid air, and as it heats up, it turns back into a gas, right? So as we turn it back into a gas, this volume of liquid nitrogen expands tremendously. In fact, the expansion ratio is pretty darn close to 700 to 1. All right? So let's trap it in something. This sounds fun. I'll give you guys a vote. Do you want Big Bang or Bigger Bang? Bigger Bang. I didn't have to ask, did I? Is that enough? Some of you probably thought I was going to do something, right? All right. So now, I have to give you a serious warning here. Never, ever do this at anywhere. Don't do this anywhere, okay? This is going to be really loud. If you don't like loud noises, you might want to plug your ears. I also have no idea when it's going to go off. So, well, okay. So, oh, my wife won't like that joke. Let's see here. Two physicists, or no, we'll do two chemists walk into a bar, okay? One of them says, I'll have H2O. The other one says, I'll have H2O too. The second one dies. I know that at least a third of you are laughing because other people are laughing. I'll explain it for you. H2O2 is hydrogen peroxide. You definitely don't want to drink it. Oh, there we go. That is my favorite thing to do ever. Should we do it again? Yeah. All right, let's do it again. Okay, we can do that. I think they did tell me I could destroy this bucket. You know what? I have these wet cotton balls in here now. I don't think I can turn the bucket over without making a really big mess. We'll just do it in here again. All right. While I'm setting it up, though, let's see here. This is fine. We'll do it. All right. We'll try to make the fuse a little shorter this time. How's that sound? Okay, so while we're doing this, I've got a question. How many of you are here tonight because you knew this was about science and you love science? Oh, most of you. All right. How many of you are here tonight because you're shopping for a major and you want to know about the science majors? A couple of you. You're actually who I've geared my comments for. How many of you are here because you thought they were going to be showing the BYU game on this TV? Oh, actually less than I thought. All right. Oh, yeah. Well, I figured you were here for the free pizza, too. Who wouldn't be, right? All right. Should be about the same magnitude sound.
Throw the popcorn in there.
Ooh, we can throw some popcorn in there. I like this idea. Somebody's thinking. I'm going to get covered in popcorn. Huh. Another joke. Boy, I didn't actually come prepared with many jokes, I'll tell you. I didn't expect to do this twice. So, I'll tell you a non-science joke, since I told you a science joke the first time. How's that, right? I'll tell you about my childhood. We lived next to a guy who had a pig with a wooden leg, okay? And we would play with this pig all the time, so we'd ask him, why does your pig have a wooden leg? And he'd always come up with a story. Oh, you know, I was out in my field one day, and the tractor turned over and trapped me. Pig came out, dug me out, saved my life. That's a valuable pig. And we'd say, well, okay, fine, but why has he got a wooden leg? So he'd say, well, you know, I was out in my barn one day, and it was hot, and I fell asleep, and there was a storm, and it came by, and it caught the barn on fire with lightning. The pig came up, woke me up, dragged me out, saved my life a second time. We said, great. Is that how he got the wooden leg? Did he get hurt then or something? He goes, no. A pig that valuable, you can't eat them all at once. All right. This one is making me nervous. Usually the longer they go, the bigger the bang. Or we did something wrong. Okay, well, I'm going to stand over here. And we'll just make sure it diffuses on its own. So while we wait for that, you know, I can't really tell you to unplug your ears because I just don't know. But at the same time, I'm not sure it's going to go off at this point. So it's a gamble. All right. So anyways, now I'd actually kind of like to turn the attention to you a little bit, all right? Shift the focus, as it were. You guys, assuming that you're all here attending BYU, are pretty squarely in the millennial generation, okay? And that means a couple of things for you as a group. You're confident, you are tech savvy, you like to collaborate with other people, you like transparency. You do not like to have a wizard behind the curtain. You want to know what's going on. You're also multitaskers, which is kind of a nice way of saying that you get distracted easily. You know it's true, right? And you kind of want it all, right? You don't just want a job. You don't want a job like everybody else has got a job. You want that awesome career with the perfect work-life balance, and it just sits on top of this hill with a pedestal and a unicorn on top, and that's your job, right? Because your whole life, you've been told that you can pursue your passions and you can live your dreams and the world is your oyster, and all of you. Good things come to those who wait, huh? That is a lot of popcorn dust. Oh dear. They're never going to invite me back. It's not as big a bang. We really can't do the small bottle now. He said, I have another bottle, and he's not wrong. Anyways, so what I was getting at is, you were told these things, right? And you have these great aspirations and this impression of how the world works. And then you graduated high school and you came to a university with 30,000 plus other students. And suddenly, pursuing your passions and living your dreams got a lot more competitive. And the path to success got a lot less clear. And the feedback that you crave and the gratification that you need isn't so immediate. And it got a little bit harder, right? And so you go around campus and you try to figure things out. So maybe you go over to the communications department, right? And they have a good idea there. And you take that idea, right? And then you go over to biology, and there's a good idea. And then there's engineering, civil, and mechanical, and electrical. And you go over to the botany department, and that smells good, right? And they go, oh, but you've got allergies, so you can't do that. And then, you know, there's law and history. And you go over to humanities, and there's no lights on, but that's okay. and there's math and physics and law and pre-med. And pretty soon, you're feeling a little lightheaded, right? It gets a little confusing. It gets a little overwhelming. Let me suggest to you, since most of you already love science, that you start your career and your training for your career with a basis in the sciences. Because what that will do for you is it will give you training and breadth and understanding that will put you way above your colleagues as you go out into the workforce. A lot like these events, right, that we've done to these demos that we've done tonight, they're not always immediately obvious on the surface what's going on, what the base principle is that's driving something. Especially with those little cylinders I tricked everybody with at the beginning, right? And the training in the sciences will give you what you need to solve those problems in your career fields. No matter what it is, you can go into any field and a basis in the sciences will help you there. And it will help you solve the challenges there. And when everybody else doesn't know what to do, you'll grab an idea, and you'll be able to juggle ideas, and you'll be able to manipulate ideas, and you'll be able to solve the problem, and it will work out very, very well for you. And that really cannot be underestimated when you're competing with so many other people. And I'll tell you a little bit about my experience. So I came to BYU pursuing a passion, all right? I probably look like I'm a lot older than the rest of you. Trust me, it's really the beard. But I was born at the bridge between Generation X and the millennial generation. And personally, I actually fall very squarely into the millennial generation. And I want everything that I feel like I should have, right? But I came to BYU as a music major. I auditioned on string bass. And pretty quickly, I realized that my passion for music and my talent in music were going to combine to make a pretty light snack, if you get my meaning. And if you look at my profile, I like to have good, hearty meals. So I needed a different career option. So what I did is I went over into physics. And in physics, my idea was to get training and education there that I could bring back into the world of music and do things with that I did not see anybody in that world or industry doing at the time. And I was going to distinguish myself with a basis in physics by doing that. And what happened is, in the physics department, opportunities just started to come. They came, and they were interesting, and they were fun, and they were replacing my passion for music with a passion for science that I didn't have. And so I followed those opportunities, and where it got me was where I currently am today at the Air Force Research Laboratories, where we do some of the most interesting and cool scientific work that I know of in the world. We are taking atoms and using lasers to cool them down so cold they become a new state of matter. And then we're using those atoms to develop devices that provide navigation without satellites and without ground beacons and without any external signal. They can't be jammed. It's just one device that tells you where you are all the time. And I'm working on developing the next generation of atomic clocks that will go into space, that will replace the current GPS constellation and improve our timing and navigation needs. And I love it. It is fun and it is interesting, and the program that I'm in has a rich history. We're actually responsible for New Mexico seeing all those crazy UFO sightings and all the aliens down there. That's the Air Force Research Laboratories. We have a telescope with a 3.5-meter mirror with its own link to the aviation world so that they don't mess up commercial aircraft. We have a device that can vaporize bulk chunks of metal from wall plug electricity. We have a laser that can take out a baseball-sized hole out of the engine block on a truck from 30,000 feet up. And we have all sorts of other cool things. We're down the road from Sandia. We meet and we collaborate with Nobel Prize winners. We have access to some of the most cutting-edge research in the world. And we advise the Defense Advanced Research Project Agency on a lot of the foremost military technology that is being developed today. And it is this career that I've always wanted on the hill with the pedestal and the unicorn on top. And it's because 12 years ago as an undergraduate, I went over to the physics department to bring something back into the world of music. Now, that's not the case for everybody, but lots of people have gone there and done the same thing and actually brought that back to the field that they initially wanted to. And having a base in the science and the sciences will give you a power in your career that actually cannot be underestimated, that will open doors and opportunities for you, and that will provide a rich and a rewarding and a very fulfilling career beyond what you could do in another single department on its own. So with that, I think we should eat free pizza.